So I'm here along the Columbia River, misty morning, beautiful day here. And for those who aren't aware, the Columbia bisects what's now Washington and Oregon, heads up into British Columbia, what's now British Columbia, and is one of the biggest rivers in the United States, certainly the lower 48. I believe it's the second biggest after the Mississippi in the lower 48. And because of that, and because of its characteristics, it's one of the most heavily industrialized rivers, not just in the United States, but in the world. You have major complexes of hydroelectric and flood control dams on this river. You have major industrial production sites. We're talking about metals processing and alloys, agricultural, shipping, barges and processing facilities, chemical production. And nowadays, a big one is data centers, because due to the hydroelectric power, you have got cheap electricity prices and reliable electricity sourcing. So major data centers are going in all up and down the Columbia River. And as a result of all these projects, the ecology of the river has been devastated. This used to be the biggest salmon producing river in the world. It was an exceptional habitat for salmon, with millions upon millions of fish coming up and down, migrating up and down the river every year. And they're almost entirely gone now. There's remnant populations of wild salmon and steelhead as well, but they're very small in number, and many of them are sustained quite artificially by spiderweb to the face, this is a pretty area here. I'm looking at some tracks down here. I think they're river otters. There's still some healthy and functioning ecology here, as you can see. I mean, I'm in this beautiful spot right now, but this is not the norm anymore. The norm is, what used to be a free-flowing, strong currented river has now been turned essentially into a series of reservoirs by the dams. So those reservoirs, they increase water temperature, they decrease dissolved oxygen in the water. They are great habitat for a lot of non-native fish species, which have flourished there in place of the salmon. Just beautiful roots here along the edge of the water line. And the dams have also, the creation of these artificial reservoirs has also altered the natural flood cycling of the river. And that has decreased habitat for flood-dependent plant species like black cottonwood, and altered the habitat, across a large portion of this region, resultingly. So, that's not even get into the other ecological issues that have been created since colonialism along this river. We're talking about Hanford, where nuclear weapons fissile material was produced during World War II and during the Cold War, and which is now a Superfund site and one of the most toxic places in the world, one of the most dangerous radioactive sites in the world. That location, there's currently huge amounts of radioactive waste that's simply stored in these leaking underground storage tanks that material is leaking and flowing underwater down to the Columbia, which is nearby. Hanford is right on the Columbia, a couple 150 miles or so upstream from where I'm at right now. And there's all kinds of legacies of industrial pollution, agricultural pollution from the major agricultural production that happens mostly upstream from here. There's a lot of wheat production, among other types of crops, that involves a large amount of fertilizer use. and pesticide use as well. So I'm kind of in an area where maybe I shouldn't be. I'm not sure. This might be private property. I can hear somebody back up there, but I'm just going to keep going. So the river's in trouble. It's definitely in trouble. One of the indicators of that, beyond the salmon, which are the most well-known, is the Columbian white-tailed deer. Columbian white-tailed deer are a subspecies of white-tailed deer who now have only 2 remnant populations remaining, right here in this area of the lower Columbia River and down in the Roseburg, Oregon area. It's believed that their historic population used to extend up towards Olympia, Washington, and down to southwestern Oregon, around Ashland and Medford area. And all that's left now is this little remnant. So I wanted to bring this up, both because it's a example of the dangers of habitat destruction and fragmentation. These areas along the Columbia have been bisected by highways and roads, by private property and fencing, by agricultural production and industrial uses, displacing what was the high quality habitat that these deer rely on. But also because it brings up a more philosophical and yet very important issue around what is a species, what's the boundary of a species. And for those who aren't aware, you've probably all been taught that a species is a very simple thing, right? It's a type of plant or animal or other type of life form that they can interbreed with each other, and so that, 2 different creatures within a species might look different. For example, dogs can look quite different, but they can successfully interbreed, and that sort of defines the boundaries of what a species is. The reality is a lot messier. Scientists, biologists have been arguing for a long time about the entire concept of species. And many people argue that it is simply inadequate to capture the real complexity of the world. That these folks remind us that the whole idea of species is a human-created concept to try and represent what's happening in reality, in nature, in evolution and speciation. Nice beaver chewed stick here. I'll just use it as a walking stick. There's beavers in here, which is great. And what they remind us is that life is not a set of discrete steps. Evolution and the development of diversity of organisms on this planet doesn't take place in jumps, so to speak, whereby you end up with discrete, easily defined species. Rather, it's a spectrum of life. And what I mean by that is, if you look at a creature like, say, the peregrine falcon, you'll see a range of traits across the different ranges that species inhabits. In certain areas, they'll be larger. In other areas, they'll be smaller, to adapt to the conditions in that climate, in that area, given the food sources that are available, the predators which may be on the lookout for them, and so on. The human conception of a species is something that we scientists made up to try and make sense of this complex reality. And this gets especially challenging in situations where species hybridize with one another. So in other words, they can breed successfully across quote unquote species lines and have viable offspring. And in other cases where you've got things like horizontal gene transfer going on, you've got clonal asexual reproduction going on, which happens in many plants and microorganisms and other creatures. And all these things result in the boundaries of what is a species breaking down. And this is actually really important because for me, as somebody who wants to protect the natural world, who's fighting against the destruction that we see today, what this tells me is that we can't be too simplistic about this, that we need to consider the web of life as a whole, as a flowing, evolving process that is moving forward in its own complexity, with a level of complexity that we cannot even understand, let alone develop effective ways to manage. And it challenges the traditional environmental approach, which there's some value in, nonetheless, but in which we see some deer tracks right here. Those might be the Colombian white-tailed. They likely are. Can't tell. Impossible to tell definitively from just the tracks, but those are from this morning. But it challenges this idea that we should simply prevent species from going extinct, and that is the best way to protect the natural world. Like I said, there's value in that. The species who have been protected with, for example, the Endangered Species Act, quite valuable. But the reality is that, again, the natural world is not split up into these easily definable categories. It is a process that is unfolding. And whenever biodiversity and resilience and abundance is lost within that web of ecological life, it is impoverished. So, for example, we could use, as an example of this, say the Douglas fir tree. It's a widely spread species. It has various subspecies across the western United States and elsewhere. It's been exported around the world for use as timber production, tree, and so on. And so there's a huge range of genetic diversity associated with this plant. This is how evolution works. It's impossible to know in advance whether or not certain genetic lineages will be more important than others when it comes to survival and flourishing in the future. So in a world of global warming, increased wildfires, logging threats, disease and mortality based on that, and all kinds of other complex changes going on in rainfall patterns and humidity and high heat events and cold weather events and timing and seasonality of precipitation, intensity, storms, changes in storms, and so on. Certain genetics are likely to be more important than others, to prove to be more fit for certain regions, to be more successful for certain regions than others. And those genetics, if allowed to, will succeed, will spread, and prevent the decline of the species. This is how nature works. And when we interfere with that process, we set up very challenging situations. And so, this is one of the problems that I have with the Endangered Species Act, with certain environmental groups that focus somewhat exclusively on endangered species issues, is that we're seeing massive declines in biodiversity even within common species, which are struggling due to various factors. Look at songbirds, for example. Songbirds across the world are declining rapidly. It's believed the main drivers are, number one, habitat destruction. Number two and number three, also habitat destruction. And then you've got things like, you've got the impacts of domestic cats and other types of non-native species on them. You've got the impacts of wind turbines. Watching some, I think there are mergansers out here fishing in the fog. Beautiful. You've got all these different impacts that have dramatically, and then of course you have the impact of pesticides on insect populations and collapsing insect populations, which are a big driver of decline in birds, specifically songbirds. So all these different factors driving down the population of birds, and yet a very small percentage of the birds species in the world, the songbird species, are labeled as extinct, threatened, or actually endangered. And that means that those species aren't getting well protected, essentially. It means that that sort of intermediate step in the destruction, where you lose the majority of the habitat, you lose the majority of the integrity of the species, of the sort of species assemblage. People talk about sometimes species, rather than using the term species, we should talk about super species or species assemblage. We should talk about web species or circle species. These different concepts that are trying to capture the idea that our concept of species is very limited and can lead us astray as often as it is helpful, if not more often. So these birds are struggling, and they don't get as much focus because they are not threatened with extinction, so to speak. So this is just an important situation. I think that, when we look at the Endangered Species Act, it's not comprehensive. It's not something that is going to solve the ecological crisis that we're facing. It has seen some success in some limited cases in finding populations of creatures that are dramatically under threat and often have already declined 70, 80, 90+% from their original abundance and diversity, and helping them to avoid complete destruction for the time being. But these laws can always be undermined. As we're seeing in the federal government today, a lot of the bedrock environmental protection laws are simply being taken away. They're being undermined, they're being weakened. And so it's not enough to just preserve a remnant of a remnant and say, we've done our job, we've done our thing here. We need to understand more deeply what this crisis is, what it's made of, the biodiversity crisis, how it's playing out, and what we can do about it. And that has led me to the work that I do, which is not just advocating for and preserving these remnants of remnants, which again I think is important and laudable work, but doing something much deeper, which is challenging the fundamental structure of this culture that we live in, this economy that we live in, advocating for essentially what amounts to a revolutionary transformation in the way we live on this world. It's not an easy thing to do. In some ways, it's much more challenging, and people will often look at it in contrast to Endangered Species Act, for example, and say that's simply not realistic. But what I think is ultimately not realistic is imagining that we can continue these sort of piecemeal, very partial approaches to these problems as the world burns, as global warming accelerates, as the mass extinction event gets worse and worse, as more and more plastic is produced every year than the year before, alongside other industrial toxins and chemicals. And as this poly crisis accelerates, and think this is enough. It's not. And that's why we need to do much more.